Welcome to the Bodhi Academy. My name is Amisha Kulaso, and in today's video we will start with our chapter 9 of class 8, friction. Now what is basically friction? So friction, it is a form of force which opposes the relative motion between the two surfaces in contact, and it acts on both the surfaces. Now to understand this, let's say we are on a football field. Okay, the minute you kick the ball starts rolling over on the ground. But did you realize that once if you kick it, it doesn't continue to move. After some time, it comes to rest. It stops, right? So why is that stopping happen? This is because of friction. So there is some kind of friction that is happening between the ball and the surface of the ground. That is the reason everything that moves suddenly comes to stop at one position. Friction opposes the relative motion between the two surfaces in contact. It acts on both the surfaces. So what is happening here when we consider the ball? What was happening? The friction of the ground was acting in the opposite direction. If the ball is coming in this direction, the friction was acting in this direction. Therefore, it was able to stop it. If friction was acting in the same direction, the ball would continue to move, but that was not the case. It was acting in the relative opposite motion of the object. Now what are the factors that affect friction? So friction, it firstly depends on the nature of surface in contact. Type of surface is very important when it comes to friction. This we will learn ahead when we will discuss more about friction. So for a given pair of surfaces, friction depends upon the state of smoothness or roughness of those surfaces. Now say if the surface is very rough, in that case what will happen? The friction will increase, and in case of smooth surfaces, the friction is going to reduce. Now if there is a very smooth surface, it has no obstacles, nothing, right? In that case what will happen? If I kick a ball on such a surface, the ball will continue to move. There will be no friction that will be acting on stopping that ball. Whereas if you look at a rougher surface, say you have maybe a football ground which is very muddy, it has all sorts of rocks, pebbles, everything is present over there. In that case what will happen? All that surface of the ground will act onto the object, that is the ball, and eventually the ball will come at rest. It is less for smooth surfaces, this we understood. Friction is independent of the area of contact. Now friction doesn't depend on how big the surface is or how small the surface is. The amount of friction that acts upon the object is always going to be the same. Friction depends on how hard the two surfaces are pressed or interlocked together. So it depends on how the two surfaces they are pressed together or how they are interlocked together, how much they are putting efforts to stick together or how much detached they are. Force required to overcome friction at the instant an object starts moving from rest is called as a static friction. This will discuss ahead. So friction is a necessary evil. Now we understood that friction can be good as well as bad. In that case, now why is this friction necessary? First, friction produces heat. Friction produces heat when we vigorously rub our palms together for a few minutes. Now if I have my palms here and I continuously rub them, what is going to happen? After some time, you are going to feel some kind of warmness or some kind of heat that is being generated. So one thing that excess of friction can do is generation of heat. Second, friction is responsible for wear and tear of various parts of machines. Okay, now if I have say two objects, okay, and I'm continuously rubbing them against each other, they are getting rubbed against each other, what will happen? Eventually they will start to become smaller. Say in that case I have, okay, we can take an example, simple example of a eraser. Okay, so I have a page and I have eraser, or I have any plain surface and I'm continuously rubbing the eraser on top of it. What is happening? It is getting worn out, correct? It is getting, the size of the eraser is reducing. So friction is responsible for this wear and tear of various parts of machine. Same thing happens in machines. When friction, when there is a lot of what you say, dragging against each other or rubbing against each other that is happening in machine parts, this also leads to wear and tear of various parts of machines. Friction decreases the efficiency of machines as a part of the machine's energy is lost in extra friction. So sometimes what happens, a machine requires higher friction energy. Okay, in that case what is happening, the energy that is being generated in the machine, somewhere it is getting consumed in this extra friction work that is happening. Friction is responsible for writing, walking and transmitting energy. Now when you are writing, if the surface is very smooth, you can easily write, right? Your pen glides like butter. Smoothly it will glide onto the book. Okay, same way now if I tell you, say you have your page, but I have asked you to place it on maybe a wall or maybe on the floor, on the rough floor which is there, or on a ground. In that case what will happen, your pen will start to get stuck at some points due to the various impurities or various what you say, roughness of the surface that is present. Okay, when you're walking, it is due to friction that we, anytime we take a step, we don't slip off. If there was no friction acting, in that case what would have happened, we would have directly slipped the minute we take a step. Because there is some kind of friction that is acting onto our shoes, it is, we are not falling down or we are able to walk properly. Friction is responsible for starting or stopping. Friction is used in gripping or holding an object with a hand. So friction is also responsible when you are holding something. What are you doing? Are you just like hanging things to your hand? No. You are interlocking two different objects. Say you are carrying a bag. In that case, your fingers are interlocking with the handle of the bag. So what is happening? Here also some kind of friction is acting. So we can say that friction is must as well as an evil. Now, how can we reduce friction? So friction can be reduced by using lubricants. Now lubricants are substances which reduce friction. Okay, so lubricants are basically like using oil, grease, powders, then ball bearings, then air cushions which are there. These all reduce friction and they all act as lubricant. Now in this case what happens is that when you want, say you are playing a game of carom, in that what happens, you need a very smooth surface for those coins to pass out very smoothly, right? To hit, they shouldn't stop in between. Now in that case what we do, we use a powder to reduce the friction onto the surface, so the coins they move very smoothly, correct? In that case powder becomes a lubricant, and what is the function that it is performing? It is reducing the friction between those coins and the surface of the board. Same thing happens with oil and ball bearings and air cushion. In some cases we don't, in some machineries it is not advisable to use oil. In that case what we do is that they have these air cushions that prevent any two machine parts to rub against each other. Friction can be increased by making a surface rough. So you can increase friction by making a surface rough. So the soles of our shoes and the tires of vehicles are treated to increase friction. Now if you have seen, we usually prefer, nowadays tires come with that gripped this thing. They have these patterns all over the tire. They are highly gripped. In that case, why is that? That is to increase the friction, correct, to make the surface more rough. If that tire is absolutely like smooth, will it glide onto the road? It will no, it will definitely slip off and will slip off the bike. So that is one thing, that they have those designed engraved design tires which are available in market. Second is same with the shoes. Our soles are usually having that engraved design, some kind of pattern which is there at the base, that increases the friction by making the surface more rough. Ball bearings reduce friction. They are used between hubs and axles of ceiling fans and bicycles. So these ball bearings are basically like, they are rings, and inside that there are more tiny smaller balls like which are there. So these balls, what they do is they basically reduce the friction by moving very smoothly. Okay, they are not producing any rough friction, they are just moving very in a smooth manner, therefore they reduce the friction. Now what is a drag? So the frictional force that is exerted by liquids, okay, by fluids is called as a drag. Let's look over here. Okay, so in this somewhere here, yeah. So what are here, what they have said, that a frictional force that is exerted by fluids is called as drag. Now when we say fluids, we are not just talking about water, liquid, any kind of liquid. We are talking about gases and liquids. When we consider gases and liquids, we call them as fluids. Okay, so fluids exert the force of friction on objects in motion through them, that is the fluid friction. Example would be there is a plane moving, plane moves through the air, right? So in that case it is a some kind of gas, so that gas or that air is also applying some kind of frictional force against the plane. Same thing happens in the sea when there are fishes. So now in this case what they do is that these bodies of the fishes and birds are streamlined in such a way that they can reduce max friction. Okay, same thing is happening with the ships and airplanes. One thing is most of them are pointed at the start. Okay, at one end they are usually pointed. Why is that? To cut through the air that is present or water that is present. Interlocking. Irregularities on two surfaces in contact make claps with each other, increasing friction. So irregularities which are there, what will happen? See, I have this. This is called interlocking. When both of my hands are fitting perfectly between each other, this is called as of interlocking. So irregularities of any two surfaces, they come in contact and they clasp together, means they interlock with each other, and this increases the friction. Now lastly, let's look at few of the frictions that we know. So first we have the rolling friction. When one body rolls over the surface of another body, the resistance to its motion is called as the rolling friction. Let's look at one example here. See, this is rolling friction. So here this rolling wheels which are there, they are rolling over the surface of this ground, correct? These are rolling over. So therefore what is happening? A friction is being reduced. Okay. Sliding. When one surface is sliding over the other surface, sliding friction comes into play. So sliding friction example is this. See over here what is happening? These are books that are placed over here, and anything that slides over the another, okay, smoothly sliding over the other. Say at those airports and all, we have those luggage transporting things, wherein you have to just put your luggage and it is going, right? It is sliding over that surface, correct? So that is sliding friction. One thing to remember here is that rolling friction is always smaller than the sliding friction. Lastly, we have the static friction. So static friction comes into play to counterbalance the applied force of the body. So whenever a body is at rest, so a force required to overcome friction at instant an object starts moving from rest is called as the static friction. So the minute object starts to move, that is known as the static friction. So that was it for this chapter of friction. Please don't forget to like, share and subscribe to the Bodhi Academy.